In this video, we're going to take a look at and compare the top 5 state management libraries in React. We're going to be spinning up the same application in each library and seeing how they differ. We're going to look at the code, the developer experience, the performance, and I'm also going to give you my thoughts as to when and in which context you should use each library. So get excited because this should be a pretty fun video and hopefully this is going to make you a better React developer. And speaking of becoming a better React developer, if you haven't heard, you should totally check out my free newsletter called Import React, which obviously, as the name implies, is all about React, and you can use it to stay up to date with all the latest and greatest in React and also get cool tips and tricks and really cool personal stuff from me that I'm not really going to share anywhere else. If you're interested, once again, it's completely free and I'll leave a link for you in the description for you to check it out. Now, let's talk about state management in React. All right, cool. So let's begin. So here I have the application and everything is going to happen inside of SRC and then inside of our features folder. I have here all of the popular state management libraries and we're going to look at all of the code for each of them. Let's first start with Redux because that is the most popular one, the one that I think has been there for the longest time, and it's generally the standard when it comes to really robust state management in React. Now, I do want to show you what application we're actually going to be building. Surprise, it is going to be a to-do app, right? This is the example that everyone uses, but everyone uses it for a reason. It's because it covers kind of all of the concepts related to actually creating and updating data, and it's a great example for state management, right? So we can do here test, we can add a to-do, we can then complete it, and we can also delete our to-do, right? So that's a simple application, and this is all running in Redux with Redux Toolkit. Cool, so let's look at the code. I'm not going to go too deep into all of those. I hope that you can kind of understand what is going on, but I will just briefly mention how they work so we can kind of see what the library is all about. So in Redux, everything essentially happens through a store. So you have one main store, and you can use a bunch of reducers to actually combine your store out of simple slices of reducers. So in our case, the only reducer that we have is this to-dos reducer. Now we are using Redux Toolkit, which makes things a little bit simpler because it offloads a lot of boilerplate that we would have otherwise have to write, but that doesn't really matter. We can now go here to our to-do slice where our reducer is exported from and see what we have. So here we have the type of our to-do. As you're going to see, each library is going to have its own local type just to make things enclosed and super simple. Then we have our initial state, which we define as an array of to-dos. And then we define our actual slice. Now again, we're using Redux Toolkit, so a lot of things are happening behind the scenes, but it doesn't really matter because everything that is important is actually here in front of our eyes. For example, we have a name here. We give it a name for our slice. That is how Redux can actually manage all of these things behind the scenes and also the Redux dev tools. Then we give it our initial state, which is going to be an empty array. And then we pass it here our reducers. So essentially our reducers, these are reducers of the slice, they will essentially dictate how the state is going to respond in response to actions. Now actions, you're going to see them, they're here at the bottom. They are actually the functions that we can dispatch from the components directly. And based on those actions, the state is going to respond through these reducers here. We're going to get to actions in just a moment. Let's just take a look at how this reducer actually works. So for example, here we have this add to do reducer and we're passing it here the actual reducer, which will receive a state property here, and then the action, which is going to have some payload. It is going to be the payload here. The payload is going to be an actual to-do, right? So we're submitting a to-do to be added. And then we're just going to state.push, and that is going to then go in our state over here, which is then going to trigger and propagate that update everywhere that we're actually looking and listening for that state. Now, this prepare function here, you don't really have to worry about it. This is just a helper function so that we can actually call the action with just text, and then it is going to actually convert the text to a to-do with an ID and complete it. But again, you see here, we're not really using it in these other reducers, so it's fine. In the toggle to do, same thing. We take a state, an action. This time it's a number, right? The payload of the action. And we're using that as the actual ID to find the to do and then to toggle it, complete it or not. And then for remove to do, we're doing the exact same thing. Now we're here with the actions, and this is again what we export and then what we use in the components. So we're exporting add to do, toggle to do, and remove to do from to do slice.actions. Again, this is helpful to us because we are using Redux Toolkit, which does that and exposes all of these things to us automatically so that we don't have to write them. And then we can just go here to our component, and this is going to be our to do component, and this is what's actually running this entire application here, right? So what do we have here? So first of all, we have our component, and then we're accessing the to dos using a selector. So in Redux, to access data from a store, you use selectors, and then you get here the state, which is going to be all of the state across all of your application and all of your reducers. And then you can pick and choose what you want to actually select from that state. And that is going to determine what this component is going to listen to and re-render whenever that thing changes. So you want to be very careful as to what you select, because if you select too many things, your component is going to re-render too many times. And you want to be really diligent with this. You're going to see that in the other libraries, we're going to have the same things to keep in mind as well. And then we have this dispatch over here, which is coming from use dispatch from the React Redux package, because by the way, you don't need to use React to use Redux. Redux is standalone, but if you want to use it in React, you want to use this package to provide you the bindings. And then you have this dispatch over here that we can use to actually dispatch our actions to our store. So for example, we have this handle submit function, which we submit when we submit the form. It gets the event, prevents the default, and then we dispatch an action called add to do, which we imported here from our slice, and we pass it here the text. That is then going to go over here. It is going to call this reducer over here. It is going to call it with the actual payload. First, we're going to do the prepare because that's how we set it up here. And then we're going to put that in the state, and that is going to be how our update is going to happen. And then we're doing the exact same thing if I scroll here to toggling something completed, right? So we're going to dispatch the toggle to do, and we're going to pass the to-do.id that we get from this context over here. And then to delete a to-do, we're dispatching the remove to-do with to-do.id, and then everything is going to work exactly as we expect. This is how Redux works. Now, when it comes to Redux, you should really use it or try to use it when you have a very large application with a very large state that needs to be controlled in a very strict manner. Because we're doing all this cool stuff with reducers and actions, it is a lot of code. It is a bit of a lot of hoops to kind of jump through to actually make your state updates happen, but that provides a nice system that you can then scale and have a really large application with a lot of state. If you're doing this for a small application, maybe it doesn't really make sense, although you could, there's nothing stopping you, but Redux is generally a solution for really big, large applications with a lot of state and a lot of components. Cool. So now let's close all of this and let's move on to our next state management solution, and let's pick over here, let's do Zustand, right? So again, we're going to go here to our app, and I'm not going to demonstrate this to you because I think you can believe me, but this is the same exact example. It works exactly in the same way. So Zustand, the way that it works is we have two files instead of one, which means that it is a little bit simpler. So over here, we have the same type, right? Type to do, same properties over here. Then we have our store. And again, we have similar terms when it comes to Zustand and Redux. We're both using a store here. But in terms of Zustand, we don't have this concept of a reducer of an action. All that we have is a store with some data and some functions to update that data. For example, our to-dos here inside of our store is going to be our array of to-dos. And then we just straight up have three functions, add to do, toggle to do, remove to do, that is going to make updates on that specific store. And that's it. And then what we can do is we can use the create function from Zustand to actually create our store. We can pass it here the type if we're working in TypeScript. And then we can use the set function here and then define both our initial state and also the functions that are going to update that state. So for example, to-dos here, we have our initial state, an empty array. It knows that it's going to be an array of to-dos because that's the type that we gave it here, so it's fine. And then we have here add to do, which is going to do the same thing. It is going to use that set function that we get here from this context, get the state, and then spread the existing to-dos from the state, and then just add a new to-do, right? The same functionality, just done in a different way. Then for toggle to do, we actually have the same thing. We have a function, it receives the ID, uses the set function, accesses the state, finds the to do in the state that it needs to toggle, and then just toggles it. And then for remove to do, it's doing the same thing. And then to actually use this, we can just go here to to-do.tsx. We have our same component, same functionality. It is just using Zustand instead of Redux. What we can do here is we can access our individual properties. So to-dos, add to do, toggle to do, remove to do. We don't have to use a selector. I mean, this is technically a selector, but we don't have to use a different selector for actual values and then functions. They all come from the same store. And then we can just directly use them in exactly the same way. In our handle submit, we can just call add to do, pass it the text. That's it. No need to use dispatch, no need to use anything else. Whenever we want to toggle a to do, we can just toggle it here based off of its ID. That works. And then we can remove it also based on its ID. That also works. Now, just like in Redux, when we had this problem of selecting things, the way that we're selecting things now, our actual to-do state is going to be rendered whenever everything inside of this to-do store is going to change, right? Which is fine because the only thing that can really change that is not a stable reference is this array of to-dos here. These functions here are stable references from Zustand, so they are not going to change. But you also want to be mindful, if you're using Zustand, you want to pull only the things that you want this component to render. Since this is the to-do component and we need all of these things, we can just safely pull all of these things without worrying about performance. Now, in terms of when you would want to use Zustand as opposed to another library, usually you want to use this for small to medium-sized projects because it offers you a really good and robust state management solution, but it's also very simple. It doesn't require you to write a lot of code. You can just define your stores, and it makes actually handling state updates super simple. You can also use this for very large applications, but then you start to have to create a lot of different stores. You start to have to manage data from multiple stores, and you may have to write some additional logic to kind of connect everything and make it fit to your specific use case, right? So you can use it for large projects, but I would stick to medium-sized projects or definitely small projects. Cool, let's close and let's move on to our next library. And here I'm going to pick Jotai. So Jotai, I believe, is made by the same people that also made Zustand, and it's a different concept to state management that functions a little bit differently. So in Zustand, we had what we called a top-down approach. We essentially define our store, which is going to contain everything that we have, and then we pick from our store and we pick the individual pieces and do things to them. We either read the data or update the data using functions. In Jotai, it is different. It is bottom-up, which means that instead of defining an entire store, we define individual pieces that we call atoms here, and then those make up the actual store and all of our data together. So we have our same to-do type over here, and then we have our first atom, to-dos atom. This is going to be an atom, and this is going to be our initial state of the array of to-dos. This is a singular atom. It doesn't have any functions to update the atom, and it doesn't have anything else besides the state of the to-dos, right? So it's a singular unit, and that's why it's called an atom. And now this atom can actually be used in components to read data directly from it, but you cannot, using this atom directly, update its own data. From that, you have to create another atom, and this is how we're doing it here. So if you want to add a to-do, you create another atom, and here, do not worry about this first argument. It is not needed. Just focus on these arguments here. You have get, set, and then text. Text is the actual parameters that you use when you want to call this atom to actually update the state. Inside of here, notice that we don't have any concept of a shared state, right? The actual to-dos, for us to get them to be able to add a to-do, because when we add a to-do, we want to keep the existing ones there. Because we don't have a general store, we actually have to use the get function and get the data of this other atom, of this individual other piece of state. Only once we get the data, then can we call the set function, pass it the to-dos atom, spread the existing to-dos, and then add our new to-do to it, right? But again, these are two different atoms, two different individual entities, and they need to talk to one another using these helper functions over here. And we're doing the same exact thing here to toggle a to-do, right? Again, the first argument, don't worry about it. We have get, set, and then ID. And again, we have to get the actual to-dos, right, from this other atom. And then we have to set them over here using the set function. And again, the same thing for the remove to-dos. And then in our to-do component over here, well, let's see how we're using it, right? So to get our to-dos, we have to use the use atom hook, and we pass it here our to-dos atom. So we're using the use atom hook. We're passing the atom that we want to listen to, and this is giving to us here the actual array of to-dos. And then to update and to get those functions, we have to use a different hook called use set atom that is going to also receive the same atoms, but this is going to return to us the functions that we can actually use to set the atom to make updates to the store. And then the rest is honestly just more of the same. So we have here add to do text, right? We have here toggle to do with the ID, and then remove to do with the ID. And this is going to work exactly in the same way, right? Again, we're building the same functionality, just using a different approach. So when would you want to use Jotai as opposed to any other library? Well, it kind of fits in the same position as Zustand. You want to use it for small to medium-sized projects. Because of its atom individualistic nature, it offers you a lot of great flexibility that you can put atoms everywhere and you can import all the different atoms and just build your state like that. But also you get a lot of complexity when you have to manage a lot of different atoms that are spread across different places, right? Because in every place you have to get the data from this one, and it can sometimes get difficult to manage if you're using this in a very large application. So for simple applications, for medium-sized applications, for relatively simple state, I would say that you can definitely use Jotai, and you can interchange it, and you can kind of pick what you want, what you prefer between Zustand and Jotai for those specific projects. Cool. So now let's close this, and now let's look at the other one. I wanted to do Recoil, but I actually have some news about Recoil that is news to me right now. So let's skip it. Let's leave it for the end, and let's go here to MobX and see how MobX MobX is. MobX is something that probably you haven't used as much. It is not that popular, but it is still nonetheless a very robust state management solution. So here in our store, you're going to see that this is completely different from the way that we're traditionally used to working with React and even JavaScript in general. So we have here our very same to-do type, right? It's the same across every single one, but then we have a class over here. So MobX is class-based. You don't have to use it in a class format. I believe that now they do recommend classes, but I remember when I was using it, you kind of have the option to do both. Don't quote me on this, but it is mostly a class-based state management solution, which is a little bit unusual when it comes to React and functional programming. So here's how this works, right? Because it's a class, we can just put some properties of the class like this to-dos here, which we type again as an array of to-dos, and we give it an initial value of an empty array. Then in the constructor here, we have this make auto observable, and then we're passing this. We're passing this, which is the instance of this specific class. What this does, this is a function that is coming directly from MobX. This is going to inspect all of the properties and all of the methods of the class and just automatically make these observable. Because some of these, like this to-dos here, is what we call an observable in terms of MobX. And these here are actual actions, or I believe they're called actions, that will change the state of the observables. And so using this make auto observable essentially just does all of that for you behind the scenes, and you don't have to worry about it. You can use a different version of this which does not have auto, which means they're going to have to manually define what each thing is, and in some cases you want to do that if this make auto observable isn't enough, but for this case it is perfectly fine. We wouldn't have to worry about it. So here we have our method add to do, receives text, and then just does this dot to do's and then pushes a new to do. Right? Simple enough. Toggle to do, ID, number, and then again, we're doing the same logic here. We're just using this dot to do's, right? We're not accessing a different atom. We're not accessing this specific state. We're just accessing the properties of this instance of the class. We're doing the same thing here with remove to do. And then at the end, we're exporting our to do store by instantiating it and then exporting the actual instance. And then to use it, we can go here to our component. And now we no longer have to use any hooks, any selectors, right? To actually get our data. The only thing that we have to do is we have to wrap our component in an observer, which comes from MobX-React Lite. There is also MobX-React without the Lite. These are, again, just like in Redux, right? You don't have to use MobX with React, or rather, you don't have to use React to use MobX. MobX is separate, and to bind it to React, you want to use this package here. This observer is essentially going to look at all of the code inside of here, what it depends on, what state it's actually listening to, and then whenever this state changes, it is just going to observe it and then rerun the component. Same concept, different way of doing it. Which means that with just this one line of code, we don't have to select anything, we don't have to do anything else. We can just directly use our to-do store. We can import it here, the instance, and we can call add to do, and then we can pass here the text, right? We can do the same thing here, to-do store.toggle to do, and then to-do.id. To-do store, remove to-do, to-do.id. And then to access the individual to-dos, we can just come here and we can actually do to-do store.to-dos. Every single time that these change, because we wrapped all of this in observer, our component is going to re-render and everything is going to work exactly as we expect. Now, in terms of when you would want to use MobX as opposed to something like Redux or Zustand, I would actually not recommend this all that often if you can actually use and make do with the existing libraries that we talked about so far. Because this having a class-based nature can really introduce some problems in your application if you don't know how to do it right? I remember I was having some difficulties with this library and it wasn't exactly, the same mental model because you're using a class for your state, but then everything else is just functions, right? It is a little bit different, but in some cases, it can actually be really beneficial. I actually, off the top of my head, don't really have a good example of when you should use MobX as opposed to something else, but I can point you to this really cool article by Photo Room that they detail exactly how they went and tried to pick a state management solution and why they went with MobX at the end. And this is a recent article, and actually they are hiring for this position. That's their whole point of writing this actual article, hoping that they would get someone that has experience with MobX to actually join their company, right? So this is an interesting read. Check it out if you're curious. So you can see, for example, Zustand versus MobX versus Redux and what the differences are and why they ended up going for MobX, right? So again, it is not that common. Usually Zustand, Redux, Jotai, it is quite enough, but in some cases, something like this is going to fill the solution and is going to be exactly what you need. And finally, let's talk about Recoil, because to be very fair, I have not used Recoil in years. When I used it, it was still in a beta, and I thought that Recoil was actually a legit library that was still actively maintained, but it turns out it is not. And the reason I'm including it in this video is because a lot of people might still use it, right? If I go here to Recoil, and I'm going to see, let's see, Recoil.js, right? A lot of people might still come here and then get started and then install this and just try to use it. But if you actually try to use this, especially in the newer version of React, let's go here to our actual application, our create next app. Let's go here to Recoil. You're going to see that we get a nice big fat error saying that some sort of, actually, this was funny. Secret internals do not use or you will be fired is undefined. Now, this is weird, right? You're like, what is this? I did a search online and it turns out they're using an outdated version of React, which no longer has this. And because we are working in a React 19 and a newer version, this is no longer available. So this is just straight up not working. And if you go here to Recoil and then GitHub, you're going to see that the repository is still experimental and it's now archived and read-only. So this project is officially dead. I didn't know this at the beginning of when I was researching for this video, and I kind of saw this and I was like, oh, I really want to include this in the video because I'm pretty sure that some people are still using Recoil. I know some companies that I've worked at previously are still using it, and you should definitely try to get out of it as soon as possible. And if you're curious, even though this is a dead library, let's very quickly just go over how it works. This is pretty much a Jotai alternative, and honestly, if you were using Recoil, just use Jotai because it's the same thing, right? You have atoms here and then you have your same atoms, they just work a little bit differently, but this is still a bottom-up approach where you have individual atoms, right? We're not going to go deep into this because honestly it doesn't really matter, but this library is officially dead, so now you also know about it. So when should you use Recoil? Well, honestly, never. Move to Jotai if you want the same kind of similar API with atoms. Otherwise, pick any of the other state management solutions that I talked about in this video. You're going to be able to find in the description of this video a link to this specific repository so that you can play around with this and get a feel for the libraries that maybe you haven't used before and see if there's one that you like better, see if there's one that makes more sense for your project, and then take that as a base and just kind of build your own project, right? It's free for you to use, and again, it's going to be linked in the description. If you enjoyed this video and you want to see more videos just like this one, make sure to leave this video a big thumbs up. You can also click here to subscribe, or you can click here to watch a different video of mine that YouTube seems to think that you're really going to enjoy. And with that being said, my name has been Darius Kozin. This is Kozin Solutions. Thank you so much for watching, and I will see you in the next video. Ciao, ciao.